going to do now. And that's primarily the algebraic part of this and solving. So we had a question, I think I wrote it out something like this. 2x is equal to 7. I think I did that the other day, right? So we can't, if we can't get the same base, then there's no possible way we can solve this question in the way it's written without probably graphing it. That's probably the only way in which we're going to be able to solve it. So what we are going to do is we are going to work it into a logarithm, which is a function on your calculator, so that we can actually solve for this. So I'm going to use what they use here. So they have x is equal to cy. So what happens is I need to change this to logarithmic form. So to change it to logarithmic form, I take the log of x. So on this side, this guy drops down and becomes my base. My exponent goes here. So essentially what happens is I have y is equal to log x to the base c. So we need to be able to go from an exponential to a logarithmic, and then from a logarithmic to an exponential. This allows us to change the base. So we currently are working in base 2 here. But if I change it to a log, I can change the base of it to base 10, something that our calculator can actually solve for. So the first thing that I would do to solve this question is I would go x equals log 7 base 2. Now I can't quite do that on my calculator. Not in the way it's written. So what I'm going to do is I can change the base to base 10 by going log 7 divided by log 2. So I would change this to x equals log 7 divided by log 2. Now I have that function on the calculator in base 10. So what I want you to do right now is use your calculator, take the log of 7. You need to use brackets for these things. Log of 7 divided by log 2, and tell me what you get. Eight zero what?
807.
Okay. So we did this the other day. We took y equals 2 to the x. So I have y equals 2 to the x, then I did y equals 7, and I found my intersection point. Okay, so again, we're not able to use Desmos on the exam, so we have to have another way in which we can solve this without the use of the graphing technology. Now we could use this on our graphing calculators and we can solve it, which is what you were just doing. But we are attempting to do as much of this course as we can, probably 98% of it, without the use of technology. So we need to be able to do questions switching from exponential to logarithmic, then changing the base to get to what we want. Now, we of course need to know a couple things. First of all, this those are inverses of each other. When you graph the inverse on a graph, what did you do? How did you graph the inverse of a function? Flip the x and the y's. Okay. So we just finished the unit on exponential equations. there's your exponential equation, right? There's your graph of y equals log x, or sorry, y equals, let's say 2 to the x. All right? Y equals log 2 to the x. This is 0, 1. That becomes 1, 0. And the graph looks like that. They're inverses of each other. An inverse has a reflection over the y equals x graph. That means if I fold it on the diagonal, I'm going to end up with the exact same graph. So I have y equals 2 to the x. Oh, didn't put the equals there. Y equals 2 x. So I have that. Now, y equals oh, there it is. Thank you. So there's log x. Say there. So there it is there. And then if I graph y equals x, you can see that these two graphs right here are inverses of each other. They reflect over top of that y equals x line. Okay? Now we know all of this. So let's look at, we had to do the characteristics of this one. Let's do the characteristics of that one. What is the x-intercept for this graph? 1 and 0. What's the domain for that graph? X is greater than 0. What's the range for that graph? Y is an element of all reals. What is the equation of the asymptote of this graph? Y equals 0. Good job. Y equals 0. Those are all the characteristics. We went through all of the characteristics and applied for this graph. Nothing changes. It stays the same. Okay? All right. Example 2. Change the form of an expression. So the first thing that we need to be able to do today, change from exponential to logarithm and logarithm to exponential. Again, the rationale is, or the reasoning behind it is, we need to make the question easier for us to solve it. Okay, for each expression in exponential form, rewrite it in logarithmic form. Okay, so I have 3 to the 4 is equal to 81, which we know is true. So to write that in logarithmic form, I go log 81 over here. Move the base down to here. And that should equal 4. The log of 81 to the base 3 is equal to 4. I have 36 to the 1/2 equals 6 equals 2. Log 6 base 36 equals 1/2. To change it the other way, the 125 stays on this side. This moves up, that moves up. 5 to the power of 3. If the base is not written in there, what is the base value? No. No. Yes. Now I want you to think about this. I have 10,000 is equal to something to the fourth. Has to be 10. If it's not written in there, it is base 10. Log base 10. Okay? Evaluate the expression. Okay. Now, in order to evaluate this expression, I am going to show you, we are eventually going to get into logarithms, and we are going to get into the rules for logarithms, let's say. I'm going to show you one essential rule of logarithm, and that is this. The log of b to the base b, the log of b to the base b is equal to 1. Okay? That's going to be the first rule that we need to know about logarithms. I'm going to go through all the rules tomorrow with you. So I'm going to show you two ways to do this first question. Log of 32 to the base 2. The first way to do this question is to do it like this. Make it equal to x. Change it to exponential. So what is this as an exponential? Right on. 32 to 2x. And what did you do to solve that? Just finished doing it. Sorry? What's the answer to this question? Yeah. Okay, so what did you do to solve this question? You just finished doing this. Get the base the same. 2 to the power of 5 is equal to 2 to the x. X is equal to 5. So that's the first way to do that question. The second way to do that question, which we're not there yet, but will be in a day's time, is to change it right here. So the second way I would do this question is this. There's two rules in here. Number one, I have log 2 to the base 2, which is equal to what? 1. The second rule that we don't know about yet is the exponent will move to the front. That means that this is actually 5 log 2 to the base 2. And if the log of 2 to the base 2 is equal to 1, 1 times 5 is 5. So this is a secondary way in which we're going to solve that question after the fact. Today, this is the way that I want you to look at that question. So let's look at the second example, B. Log of 10 to the 1,000 equals x. So this one's a little bit more complicated. 10 equals 1,000 to the x. All right. I need a common base here. What's the base? Is it 100 or 1,000? 100. My bad. Went too many zeros. Okay. Okay. What's the common base that I need to get to? 10. This is 10 to the 1. This is 10 to the what? 2. X. 1 equals 2x. X is equal to 1/2. Good so far? Okay. That's it. You can start in on page 263, and you'll just get lots of practice on that today. And I'll go through So tomorrow is the transformations of the logarithm graphs, and then we'll get into the rules of it. So we are gonna clip a little bit here, just to get through this. Okay, again, we're trying to make up a little bit of time, and this is the way to do it, with something you already done and know. Okay? So finish up your review on 7 and then get